This is linear programming. Okay, linear programming is just a math technique. A math technique used to solve real world problems. Yeah, but whenever we solve real world problems, that's when the topic is difficult.
That's really true, honestly. Well, the problem
Made up of constraints and an objective function. It's a math technique used to solve real-world problems made up of constraints and an objective function.
So does that pretty much say that normal math doesn't solve real-world problems?
This is a technique designed specifically for real-world problems. So yes, generally speaking, they're not developed to solve specific world problems.
Exactly.
Yeah, behind the or next to the pencil. All right, ready? Objective function. The objective function is a function that must be optimized. When I say optimized, that means maximized or minimized. Like we want the smallest value or the biggest value.
And or, like which one?
Yes. It could be both. Usually it's one or the other, but it could be both. Like usually it doesn't make sense to do both. Like say real world problem would be like minimize cost or maximize profit. Like you don't want to do minimum profit. You don't want to do maximize cost. Unless you're working for the government. Sorry, that needs to be all right. Okay, constraints. Constraints are inequalities that limit the problem.
Let's see,
Maximize, yeah.
maximize
Or minimized.
They're so glad for this topic.
If you don't catch anything from the constraints, just catch that it's an inequality, okay? Basically, it's the inequalities in the problem. Do I have something on my notes? You keep staring at me. All right, the feasible region. What's the feasible region? I didn't like that thing. Oh, here we go. Number combinations that make up the context of the problem. Problem, this idea of number combinations really doesn't make sense. But we're solving these on an XY coordinate plane. So each point is a number combination, right? Because it's always two numbers. So that's what I mean by all of them. It's the number combinations that make up the context of the problem. For example, if we're talking about selling newspapers, you wouldn't talk about selling -10 newspapers. Right? So negative numbers are outside the context of that problem. Did that make any sense?
How would you sell negative newspapers?
You don't. That's why you don't sell negative newspapers.
Is it
Negative
buying
number.
newspapers?
Say what?
Do you buy newspapers to sell negative newspapers?
Do you chase parked cars? All right.
Yes.
Okay. Now, what you don't see on this diagram is that the original document had this shaded. Okay. So the unbounded feasible region looks like this. It's shaded here. So all this is shaded. It's unbounded because it's not blocked on top. It's not closed in on top.
Oh, that makes sense.
Okay, so that's an unbounded feasible region. So that means any ordered pair is a possible situation in this problem. Any ordered pair. What would be an unbounded problem?
2 plus 2.
I don't know. All right. Most of the time, my mind goes to this kind of problem. Like, it makes sense to be bounded. Like, you want to sell lots of newspapers, but you only have, say, 500 newspapers. Okay. There is a limit to your supply. So usually, real world problems look like bounded feasible regions. All right. So this one, the shading is here. Okay, now the shaded region itself, not particularly important, except to point out where the boundaries meet. So like these vertices. All right, so here are some vertices. These vertices is where the answers to the problem is going to lie. The vertices are where the answers to the problem are going to lie. Oh, so Aiden, we didn't do this last year.
Yeah, that's why I'm paying attention.
All right. So these vertices are where the answers are going to lie. So here are the vertices for the unbounded one, and here are the vertices for the bounded one. So like some of these you can usually ignore. Like 0, 0. You're not going to maximize profit by not selling any newspapers.
There you are.
What?
Self-subscription.
Right. If your company is in the process of selling newspapers, selling none of them is not going to maximize your profit.
Selling nothing.
Right. So usually it's a possibility, but you're not going to do that. Right. So it's probably going to be up here. Maybe you're selling. Maybe you split it into weekly paper and the Sunday paper. Right.
Facts.
You would sell like mostly weekly papers or mostly Sunday papers. All right. Okay, so this is after you set up the word problem. Like you've given the word problem, and these are your constraints. Okay, so these are my constraints. Okay, and this is my objective function. So all these inequalities are my constraints, and this f of x, y, that's my objective function.
What is objective function?
That's the function that you want to maximize or minimize. Okay, for example, so the x and y could be the number of weekday papers, and y could be the Sunday papers. And let's say you make 10 cents on, or $10 on the Sunday papers, and $1 on the weekly papers. So that's why you have x and y. 2 different variables. One will be like the Sunday paper, the other will be like the weekly paper. All right. Now, make sure you try to write as small as you can, because we've got a lot of work to put in this little space. Okay? Or do it on separate paper, either one. So what I want to do is solve this for y, x plus 4y greater than or equal to 12. Solve that for y so I can graph it. Okay? So I'm solving that for y. I got y is greater than 4y is greater than or equal to negative x plus 12. So all I did was move the x from the left side to the right side. Right, Myasia? Myasia? I can't shout. I'm recording.
You should scream.
Okay. Okay. Alright. Continue to solve for y. I'm going to divide by 4, so it's y is greater than or equal to negative 1/4 x plus 3. Is my voice that soothing?
Emily said that you
Really-
screamed at her one time.
really
Yes, I did.
I'm
I'm
like,
like,
I act like
she was up till 2 a.m. with
Wow.
me.
I'm not
Wow.
resting my eyes, but I'm barely asleep on things.
Okay.
I don't know.
Oh, you need to write it down.
All right.
Your name.
Okay, so let's go ahead and graph this. So it has a y-intercept of 3. So 1, 2, 3. Right, that point might be important later. So we have a slope of negative 1/4. So I go down 1, right 4, down 1, right 4, down 1, right 4. Let's connect those. Okay.
Can I have a ruler?
Okay.
Yeah. No, yes, or something. I don't know.
All right.
That's-
Now, if this one said greater than, so I'm going to shade above. Now, I don't want to shade it. I don't want to shade it now. I'm just going to draw an up arrow, meaning which way I want to shade this thing. Okay, so that's the direction I want to shade it. Now, let's go to the next inequality. It's x minus 2y is less than or equal to 0. So I'm going to move the x to the right, so it's negative 2y is less than or equal to negative x. You okay with that, Anthony?
No.
Do you understand how I got negative x over here?
No.
Alright, see the positive x over here? So when I change sides, I change signs. So the positive x on the left becomes negative x on the right. So technically it's negative x plus 0. But anything plus 0, I mean the 0 just goes away. So that's why I have one from x on the left to negative x on the right. Now I divide by negative 2. So when I divide by negative 2, the inequality changes directions, and that becomes 1/2 x, right? So that's like negative 1 divided by negative 2. I just rewrite it as 1 over 2.
When you divide that by 2,
I divide by negative 2. Right, to get rid of the negative 2 in front of the y. Alright, let's graph this one. So that has a y-intercept of what?
0.
0. So I start at 0, and I have a slope of positive 1/2. So I'm going up 1, right 2, up 1, right 2, up 1, right 2. So alright. You really don't need
It
this
is kinda like-
big of a grid.
It looks like
So why did they give us a big
Alright, I got 2 more. I still have 2 more to go. Alright. I got negative x plus 2y is less than or equal to 6. So I'm going to move the x to the right. So it's 2y less than or equal to x plus 6. Divide by 2. I get y is less than 1/2 x plus 3. So remember the x has a 1 in front of it. When I divide by 2, that becomes 1/2. 1 over 2 becomes 1/2. And that 3 comes from 6 divided by 2. So, I forgot to draw the arrows on this one. This is going up. This was y greater than 1/2 x. I forgot to put the arrows on there. So those arrows. Right? So I want to shade above that. Okay? I wanted to do that before I forgot, or I did forget. Alright, let's do the other one. Let's do the 1/2 x plus 3. So I have a y-intercept of 3. Half x, so it's up 1 over 2. Up 1 over 2, so it's parallel to the other one. Okay? But this one is less than. This one is less than, so it's going to shade downwards. So I'm going to shade towards the other one. So far my boundary is here, right? So far my enclosed boundary is this part right here. Looks like the sharp end of a sword.
So when you shade that, you're gonna shade that tiny triangle at the bottom too?
Yeah.
No, this is not part of the answer region.
Or no, that one in between the parallel line.
Here?
No, down one.
Here?
Down to the left.
That's not down?
That one, yeah.
That.
That.
Right.
Would you shade
No,
that as
because
well?
this says above this line. See these? It's above that line, so I would not shade this part. I would shade this part.
Okay.
But I still have one more line.
Why is the
Right.
light going down though?
What's going down?
Like the arrows, why is it going down?
Right. This was the less than line. This was the y is less than 1/2 x line.
Oh, so it's less than.
So this one, the higher line, you shade downward because of that less than sign. Okay? Now let's do x less than or equal to 6. So what kind of line is x equals 6? Vertical line. So I'm going to draw a vertical line through x equals 6. So 1, 2, 3, 4, 5, 6, vertical line. Which way do I shade that? To the left or to the right? To the left, right? X less than or equal to 6 is to the left. So my shaded region is right here.
There's that little,
The trapezoid. So there's my shaded region.
That's not too
See what
hard.
you're doing.
I mean,
Right. We spent a long time graphing inequalities,
yeah,
right?
it's just time.
It was the build up for this. Wait, I'm not done yet. I'm not done yet.
I said it to be shaded and you didn't even believe me. I don't know. I didn't believe you.
Okay. It's okay. Alright. Now, let's identify the vertices. We're identifying the vertices of this feasible region. Right, so that's the feasible region, the shaded area. Right, that means this makes sense for this problem are the numbers that are here. Okay? Now, what's the coordinate here? This one right here.
6.
6, 6. 6, 6. So I'm going to write it 6, 6 right here. Okay? 6, 6.
Do we have to label which vertice it is, or just like
No. What's this one?
3, 0,
3.
0, 3?
0, 3. What's this one? So you're looking at your own paper because I know I'm blocking everything.
4, 2? No.
2, 4.
2, 4.
Yeah.
And what's this one?
6, 3.
That one is 6, 3.
3, 6.
6, 3. Right? Remember, it's always the x first. The x direction. The horizontal direction first. Okay, so what do I do with those? You go back. Remember this other equation we had over here? This is the objective function. And looks like I messed up my space. Alright. Alright, so I'm going to take these ordered pairs. Remember, this is x comma y. So I'm replacing it. The x was 6 and the y was 6. So it looks like this. You say f of 6 comma 6. So that's the ordered pair that we're plugging in. We're plugging in the 6, 6. That's going to be 6 plus 10 times 6, which is 66. Right, that's just me working it out. 6 plus 10 times 6. 10 times 6 is 60. Remember, order of operation says multiplication before addition. So that's 60 plus 6 makes 66. Do that for the rest of them. So let's do 0, 3.
Do we have to plug this into every single one?
Can I use the bathroom?
Yes. Wait. So that's going to be 0 plus 10 times 3. So that's 30. You only have 4 points. And you're only just plugging it in.
Isn't the blue one 4, 2?
This one, you're saying that's 4, 2?
30.
Yes, that's 4, 2.
Oh, I was right with the original one.
Okay, that was a mistake, that was 4, 2. So that's 4 plus 10 times 2. So that's 24. And the last one is 6, 3. Is 6, 3 right? Yeah.
Wait, there's 2 equal signs.
So it's 6 plus 10 times 3, or 36.
Do we have to work these out?
I just did.
That's it?
Yeah.
Those are the answers?
We're not done yet.
Oh.
You have to solve these?
We've solved them. Now we have to answer the question. Because it said, find the maximum and minimum value.
Maximum is 66,
Oh,
minimum
so-
is 24.
Alright, so here's how we're going to answer the question. There is a max at 6, 6 of 66.
Can we just say maximum equals 66? Or?
I'll need the coordinates where it exists. And there is a minimum at, where is it? What's the minimum?
24, so 2 and 4 or something.
Oh yeah, I forgot. This is messed up. This is a mistake, right? That's
Wait,
4, 2, not
Is
2,
it just
4.
the backwards of everything for this problem specifically?
I don't understand the backwards part.
So look over the coordinates. You just flip the coordinates and it equals the number.
Oh, yeah, that's just accident.
Actually, most people to number.
Alright, so that was minimum at 4, 2 of 24.
Is it gonna be like backwards all the time?
Say it again?
Is it gonna be like that all the time?
Usually you're going to answer just one of them. Either the min or the maximum.
No, I mean like how 4, 2 and then 24.
No, I think it's just like
No, that's because of this. That's because of this. Like, you're not going to have the same function every time. Right? If you're dealing with money, you might have like $10 for sodas and $20 for...
That's an expensive soda.
Yes. We're going all out. Alright. Now, I'm going to do one example from each side of your homework. Okay?
This is our homework.
Yes. And I didn't think to bring one. Or did I? Nope, I didn't. Okay. You can stare at this while I go get them.
Can I go to the bathroom now?
Yeah.
And like the thing is, right? I
Huh?
lost my agenda. So like how did that how do I do that?
I guess you don't get to go then.
You can use mine. I guess I will.
No, here, I have a pass.
You got a pass? Oh my god, I love you. You are a beautiful Asian man. Nothing weird though, but like, yeah.
You know that was recorded.
Oh. Hi.
To remind you of this conversation when you're mad at
That's racially
You don't get it?
No, I don't think that's okay.
Oh.
I think it's okay. I don't think it's like
Alright. Okay, pick one from this side, but don't pick 2 or 3.
12. Oh, wait,
I'm doing one from each side. Okay? Okay, I heard 5 and 6.
6, 6, 6.
3.
Alright. Okay, guys, you'll find that this side is incredibly easy. The back side, not so much. Okay? And I'll choose the back side. Alright, so number 6. All they're asking you to do on the front is identifying the vertices. So here are the 5 vertices of number 6. And you're going to just list them. Just write them on the side. Is this focused?
No.
There are 5.
There you go. Yeah, there's 5, right?
Yellow.
You see them? Alright, so here, the first one over here is 06. So just write 06. And then this one is 3, 6. 3, 6. And then this one is 8, 2. And then 8, 0. And what's the last one?
How do you know which one comes first?
X is always first.
No, I mean like. in
Zero,
the-
zero.
Oh, so your question is, does this one have to be first? The answer is
Yeah,
no.
like
The order doesn't
stuff.
matter.
Oh.
Order doesn't matter. Yes.
For the ones that aren't bounded, do we just write unbounded?
No, you just give the ones that are on the bottom.
Oh, okay.
So there's two unbounded ones. Okay, the one I'm going to do on the back is an unbounded one. Okay.
Okay.
All right. So that's all you're asked to do for the front. All you're doing is identifying the vertices. That's it. Easy. That's all you're doing. All right. So number 6 is complete. Okay. I'm going to do number 12 on the back.
6 and 12.
Okay. All right. So I'm doing number 12 on the back. So let's graph this first. Y is great. So I'm graphing this one. Y is greater than or equal to negative x plus 6. So that's a 6 and has a slope of negative 1. So it's down 1, right 1. All right. And then the shading is going to be above, so it's going to be upwards. Okay. Then the second inequality. Oh, by the way, this is missing one. It's missing x is greater than or equal to 0. All right. This one has a y-intercept of 4 and a slope of negative 1/2. So it's down 1, right 2, down 1, right 2, down 1, right 2, down 1, right 2.
Wait, what?
And that's going up.
And that's going up as well. All right, and then the negative 3x plus 10. So that's going to start at 10. And then I have a slope of negative 3, so it's down 3, right 1. Down 3, right 1. Down 3, right 1. That's also shaded above. And y is greater than or equal to 0. That's the x-axis. We just want this to be above the x-axis. So above the x-axis. Oh, I drew a cricket, and I'm using a ruler.
Wow.
It's down here.
You don't care.
Okay, so you have to shade. The shading is here.
That was a confusing one. I'm glad you did that one, 'cause you were all real close.
Okay? Now, let's find the vertices. Let's find the vertices. So let's start with the top left. So there's a vertex right there.
0, 10.
0, 10. Where is the next vertex? I know it's really confusing with this. 1?
2,
So that's a dot, but that's not a vertex.
2, 4.
So the next one's here. So look for the intersection.
2, 4.
2, 4. And where is the next intersection that's next to the shaded part?
4, 2.
4, 2. And where's the next one? There's one more.
8, 0.
0.
8, 0. Very good. So that's what you do for this. Okay? It's a little tedious. Enjoy today because the rest of the week is tough.
I thought you said today was tough.
No, I said this technique. Okay, I can't say it done while I'm being recorded.
I wish I read that.
All right, so now you're on your own. I'm going to shut off the video.
Bye, everybody.
No, I'm just turning it off.